Hi, I'm Rich with Inside HPC. We're here at SC15 in Austin, Texas at the IBM booth, and I'm here with Doug O'Flaherty. How you doing, sir?
I'm having a great time. It's really great to be back at SC15, and being back in Austin's a total hoot. We've had a great time here when we're talking about data centric computing and the ability to use spectrum scale and platform LSF for doing cognitive computing. Customers, partners, the world has been talking about how we can really bring together file, object, and even business analytic workloads in amazing ways. It's been fun.
Okay, so there's a lot more to it than just the spectrum scale software, what used to be known as, GPFS, right? There's more to it than that, isn't there?
There is a lot more to it,
yeah.
And we had 175 people in the user group meeting yesterday talking about all the different ways that they use it, and including for e-commerce, including for analytics, including high-speed data ingest, all sorts of stuff. But we're also trying to make spectrum scale and the platform LSF cost effective. We're looking at putting stuff more out in the cloud. We've got a big storage preview coming on over here where we're talking about cold storage for IBM spectrum scale in a way that becomes cost effective for that long-term data retention. But let me show you something that's really interesting around the corner.
All right, Doug, here we are, and what do we got here? What are we looking at?
We're looking at an incredible opportunity to be able to run DB2 and standard data analytics on top of spectrum scale, on top of our integrated rack system, the Elastic Storage Server, also commonly called ESS. But what makes it really different is within that same data structure and then within that same platform, within that same cognitive computing, we're bringing together sentiment analysis as well. I really should turn it over to PC and have him walk you through a few steps of it.
Okay, PC.
Thanks, Doug.
Can you show us how it works?
Sure, absolutely. So this is showing a traditional data warehouse, OLTP workload, and we are augmenting it with Twitter sentiment analysis. And so the opportunity here is how can we take this new social media data and use that to improve our business results. And it's only possible because we are running it on top of a common data plane supplied by Spectrum Scale, running our Elastic Storage Server. And so we get this information and we say, hey, let's create a new marketing campaign that says, if you are a female, you're from Miami, and you have a Twitter sentiment that's positive about our company, we're going to generate a special offer for you that gives you 30% off on sunglasses. So when that customer logs in to our web portal, we identify them as such, and we generate this special offer for them that gives them 30% off on sunglasses. So we are now using social media data to improve our retail business, all on top of Spectrum Scale and our integrated Elastic Storage Server solution.
That's got to happen real fast for it to be effective, doesn't it?
It's all in real time.
Yeah.
We're sucking in data live from Twitter and doing this on the system live right here on the show floor.
Exciting. So what is that rack over there? What is this, Doug? Can you tell us more? Yeah.
And what we're doing here is, so this is the live Elastic Storage Server that is computing all this Twitter sentiment analysis and also running at the same time the OLTP data warehouse workload. We have the analytics servers that are running 5 different applications all on top of the same data plane. We have DB2, we have WebSphere, Cognos, Big Insights, and SPSS, combining to create a new system of insight that can improve your business results.
So quite a pipeline of data coming in, and you're able to manage all that with this.
Right on the show floor.
Yeah. Excellent. Well, thanks for sharing that. So what do we got here, Doug?
Well, a couple of things to think about, right?
Yeah.
We think about how fast at supercomputing we need to move big chunks of data. We're talking here real time. We're talking about the ability to move I/O in and out all over the place and making this accessible for everybody. So one of the other things that's happened here, exciting for Spectrum Scale and the cognitive computing and platform LSF working together, is making it easier. So let me walk you over and show you something that no one who would have said the words GPFS would have probably expected, a brand new, exciting GUI for Spectrum Scale.
Okay, let's take a look. All right, so what are we looking at here? We got kind of a demo.
Yeah, so this is the Spectrum Scale GUI. Here's the dashboard that we use for monitoring the entire cluster. Out across the cluster, we can look at things like our NSD server throughput, where we have latency, which of our nodes are pushing the most workload in the entire cluster, what does our network interfaces look like. So in between the actual storage hardware, the nodes, and the network, we're really bringing together the entire cluster into a single panel. Now I can get a lot further in if I want to do monitoring, some deep performance troubleshooting. Here we're running a file and object mixed workload, so I can see that I have 4 protocol nodes they're pushing a certain amount of GET requests across the cluster, and I can do a correlation with what we're seeing on the object level down to the client level in terms of latency, and as I rewind back in time, I can see that I've actually had a swap in my workload where another 2 set of protocol nodes took over around 6 yesterday.
So this is a little departure from the old days of GPFS with this GUI. This looks pretty powerful.
Yeah, it's definitely powerful. Able to monitor very large clusters very dynamically.
All right, Doug, so this being HPC, we're always worried about what's coming next. What do you got for us now?
Well, one of the things I want to talk a little bit about is what's coming out of our research organization. The guys from IBM Albany are always pushing the envelope. Part of our DNA has been this high performance, how do we get to be exascale, how do we make things really huge? This is why we're here at Supercomputing, right? Is to really push the envelope, and our research team is always doing it. So you've seen a lot of what we're talking about here as being cognitive computing, the software-defined infrastructure, making it easier to move data around with file, with object, and with analytics. Let's talk about exascale. Let's talk about what's up and over the top.
All right, Dean, what do we got? What are you showing us here today?
So this is a research project out of IBM Research Center where we're looking at scaling file systems to really the next level with exabytes and at exascale level. So in one file system today, you cannot get these 3 items, which are really high performance, unlimited capacity, which means scaling to exabytes and trillions of files and objects, as well as highly available, which means that the entire file system will never completely fail, that you can fail parts of the file system, but at no point will the entire file system ever be down as an entity. And that'll allow applications running to continue running while certain parts of the file system will fail and other parts will just keep on going.
So normally I might have to sacrifice one of these dimensions to get there, but it looks like a balanced approach.
That's exactly right. We're trying to get all 3 of them in one system such that people don't have to either chop up their file systems into many different silos, and then that way they run into capacity problems where they're constantly swapping their capacity from one of those silos to the other. So we want to make sure that people can create one large system and just use that one system as a single system. And so we're building all of this based on spectrum scale and creating failure domains inside the system such that if one failure domain fails, then all the other failure domains would continue to be active and all of the applications running in those surviving failure domains will not be affected. In addition, those applications will experience a level of isolation in that when they're running in a failure domain, all of their activity is completely isolated from all the other activity such as distributed logs or I/O that is going on in the other failure domains in the system. So that is also shown here in this diagram where we're creating multiple layers of abstraction where you can take the file system tree that exists at the top, and that's what the user sees, and then compose that into a series of failure domains down at the middle layer, and then abstract that set of files and data down onto your physical storage system. So in this example with Spectrum Scale, all of the data is stored in the Spectrum Scale system and then stored on the actual physical ESS hardware at the bottom.
Well, as you know, Obama's NSCI initiative talks a lot about usable exascale, and it would seem to me that resiliency has to be a part of that, other things breaking before you get the work done, right? So
it's exactly true. And so in typical fashion, the HPC community, supercomputing and IBM research is pushing the boundary of how do you put different types of data and more data together. And then we're showing off here how that scale trickles down into commercial applications, analytics, e-commerce, and even out into the cloud. So it's an exciting time to be doing cognitive computing with software-defined infrastructure at IBM.